an exponential and a quadratic function, what defines those differences? The rate of change, okay? Do you need the y-intercept? Yes. So should you identify the y-intercept pretty quickly? Yes. But remember, each of the different functions have a different rate of change. Because they have a different rate of change, you want to know what the rate of change is before you start dealing with or writing that equation. Because if it is a linear function, right? If it's linear, what are the equations we should be thinking about? Okay, y equals mx plus b. There is another option that's very similar to that. Y equals a plus bx. Remember, the idea is, so like, where's my slope, my rate of change in the first equation? M, right? What's my slope in the second equation, though, or my rate of change? The b, right? What is defining the fact that it's my slope, my rate of change? The times x. Why is that multiplication important? Because that is repeated addition. A linear function has that constant additive rate of change. So we want to pay attention to that, okay? So it is the rate of change that you need to identify. That's what makes something a linear versus an exponential. Because what's happening in an exponential function?
Collins.
Huh?
He's
He'll
buying
be in
the
here soon, he's
Will
buying.
you give
Okay, I
me
can do
Collins?
that, yeah.
Thank you.
Alright?
Yeah, I gotta see that.
So exponential, what makes something exponential?
Is it repeated multiplication?
There we go, right? That multiplicative rate of change, a constant multiplication, is what's going to make it exponential, which is why, where's the variable located that time around? In the exponent, right? So what is the general equation for an exponential?
Y equals a plus b.
So let's talk about that a second. In this case, what are you doing between the a and the b? You're adding, but what did you say makes it exponential? The repeated what?
Multiplication. I'll get it one day.
Okay, so you need to multiply by b to the x. Notice we started at a and then we repeatedly added. Here with an exponential, we start at a and we repeatedly multiply. Okay, and so that's an important detail there. CD. Okay. And then there's lots of different equations for quadratics depending on the information given. But what makes it quadratic?
You said $1?
You said sit down, call.
Oh, okay.
What key detail are we looking for with a quadratic?
It's an increase and decrease.
Yes, it's a parabola.
Okay, so parabola in the graph, it's increasing and decreasing.
Linear rate of change.
It has a linear additive rate of change. But what is it? What is the key thing in the equation?
I don't know. Why
Because we only get.
There's something else that I need. Something with the exponent. It's squared. This is why you cannot just say it has an exponent. And that's a big thing to notice, right? The second set of differences is where we find our constant additive rate of change, right? And it's the, so like if it was x to the third, where are you going to find your constant set of differences? The third. And if it's x to the fourth, it's going to be in the fourth, okay? And so we'll explore that more heavily in the future, but yeah, it's x to the second. And I will say this, if you ever get into calculus, you'll actually find out a little bit more about why it's at that second difference and that third difference. But yeah.
Are you gonna give me a 0 for today for not doing the movie yet?
No.
Okay, making sure,
Not-
because
not today.
what you said.
I-
Yes.
But I knew I had to get started without people today.
I'm sorry, I'm just gonna take them out.
Yeah. So is the function linear, exponential, quadratic, or none of the above? No one said linear. No one said none of the above. We were split between exponential and quadratic. What are we thinking now? Exponential. So if you're saying it's exponential, it means we're repeatedly what?
Multiplying.
Times 3.
A constant multiplication.
So times 3 times 3. Do y'all agree?
Wait.
I'm and disagree with that statement.
Oh,
Oh.
Forget it's
Oh,
not
I mean,
down.
yeah.
Okay, so maybe division by 3, but I don't necessarily recommend you writing it as division by 3 because it would make writing the equation harder.
Right as a
1/3.
fraction of the fraction.
So instead of doing division by 3, multiply it by 1/3. And notice that it actually helps you with the fraction side of things, because if you do 5 and it's understood to be divided by 1 times 1/3, it's literally 5/3, right? If I take 5/3 and I multiply it by 1/3, 5/9, right? Multiplying by the fraction is the better way to go. And also, once you start to train yourself this way, it makes a lot of sense, because it's 45 times 1, and then what? Divided by 3, right? So that's why you want to write it as that fraction. And so finally, the equation that we were struggling with, okay? Do we think it's 2x plus times 3?
No.
No, probably not. What do we think?
It's times 1/3.
Okay, so first off, we should automatically know that it's times 1/3, then what with that 1/3?
Raised to the x.
Raised to the x. It's exponential, so it's raised to the x. That's my common ratio. What is a though? So don't forget.
You gotta get your zero.
Okay, so what do you mean? So like this needs to be 0?
No, you gotta get your y-intercept.
Okay, so we need a y-intercept, and we always know that the y-intercept is when x equals,
Zero.
so you have to go a little bit further with this one. So what am I gonna get?
5/27.
Okay, so notice 5 times 1 is 5, 9 times 3 is, we good with that idea? Okay, I will let you know, because it's been so wicked crazy and stuff like that, we have not had an assessment on linear versus exponential, but I would plan on that either Monday or Tuesday next week. So we'll get some more practice with bell ringers, but we need to be ready for a linear versus exponential understanding check. And that's actually one thing I was going to say is, with this, I'm still obviously taking it late, but I'll probably make the understanding check on Tuesday so that some of us can get this done and turned in tomorrow, so I can give you feedback over the weekend, and probably send out some solutions to help us.
Is my power score just being done, or you have you put in our exam yet?
I have not put in the exam yet.
Okay.
Y'all's is the last class that I have to do, and then once I finish scoring it, then I have to actually put it in the Excel file to actually figure out the scores. I'll have it done during Patriot games today though. I spent the first, not even half my weekend, I spent Saturday, Sunday, and even part of Monday finishing up late work. Or Saturday and Sunday, and then started grading on Monday, I think.
I was like, I made 92 on my anatomy exam, and I'm so excited.
That is exciting. Alright, so here's our agenda. We should already have our big ideas concepts sheet out. And then we will get into the textbook with whatever time we have remaining. We will not get to exploring features with parabolas today. Hopefully, maybe tomorrow.
So other than that,
Huh?
my
9. Maybe they changed it, but I heard 9 last.
I heard 9:15.
I heard
I think it's, am I good?
They told me that it would be sometime after 9, but it'd be close to 9. Is what they last told us. Say
Am I
again.
good, like, what did I miss, like,
I'm
right?
just not prepared.
Any worksheet, any?
We started on we continued working on the textbook
Teachers,
stuff.
excuse this interruption, we took a little extra time selling tickets this morning, but the students should be in class. In about 30 seconds, everybody should be there. You might want to look outside your door. Make sure
They
you're.
were taking
All right.
so
So, here's something I need y'all to hear me very clearly on, okay? Because I saw a student in my third block who already had all of the definitions or major concepts for this entire sheet worked out, or written out,
No, I thought it was homework.
okay? But I told y'all to only go through common differences or ratios, because we haven't even covered any of the other concepts. And if you have all that filled out, then I would caution you, because that probably means you just Googled some stuff. The whole point of this graphic organizer is for you to look at the lessons we have done, and then to reflect on what we discussed and the key ideas from those lessons. So, first off, what was the very first lesson that we covered? The dream job salary task, which was all about what type of functions? Linear versus exponential.
Is with Shannon in here? Hey, with Shannon, I'm
There you
so
go.
sorry.
Okay, so linear versus exponential was that dream job salary task, and this is literally what I would do. Hey y'all, this is literally what I would do is I would think through every lesson that we did, and then I would figure out what concepts showed up there. So the linear versus exponential, the dream job salary task, which of these concepts did we talk about? So we've got
Wait, yeah.
Quadratic.
dream job salary.
Increase drop salary. And
That's
You can do dream job salary for the first three. I would 100% agree with that. Is there anything else that we can put it with?
Common differences.
There we go, right? So now here's the thing. Is this the only time we've covered these ideas?
Mathematics is the only one I don't have. Or
Mathematical representations. We did cover it with that, and so this is again why I'm giving y'all some time to ask questions, and I'm trying to model this for you so that you understand what I'm looking for moving forward, because I'm not going to go into this level of detail. That's something I need to do a better job of modeling early next time. Okay, but I do want to point this out. Have we seen linear functions show up anywhere else that we might be able to reference? The homework, yeah. Take it. Okay, and then so, yeah, we do want to make note gold rush for the quadratic. But my question is, like, right now, is there anywhere else linear versus exponential? And aren't we looking at it right now with the cat's out of the bag? That's that M1-17
Is it function?
to M1-27, right? So maybe textbook. So maybe put like a little dash to separate them. So this is a lesson, and so you can put the lesson name, or you can just write down the page numbers, right? And you can do like abbreviations like that to help save space. Like if you put something like TXTBK, I know that means textbook. All right. Does that lesson from the textbook help us see any of these other ideas?
Quadratic.
Yeah, because we did talk, we're about to get into quadratics with that more heavily. So textbook M1-17 to M1-27. Yeah. And the common differences and ratios kind of showed up with that within that task, but that's probably not where I would primarily focus. Okay. I think the mathematical representations did show up within Gold Rush as well.
Do you mean like tabular and algebraic? Okay.
Those are mathematical representations. And so I want to point this out to you. The whole point of this graphic organizer is if you know, hey, I'm working on this homework and I need some more information about linear or exponential, now you know what lessons to go look at.
What does tabular mean?
We'll come back to that in a second. Okay? But I want us to understand how these lessons or how this thing is supposed to help us. And so I am just now making this due tomorrow because we had midterms and all those other things happening, and then we didn't see each other Monday or Tuesday. Or well, some of y'all did not see me on Friday. Instead we went to watch someone get knocked out.
And knockout. And knocked out. It was mutual, thank you. Twice, both times. Both of them felt like.
Those are called knockdowns.
Thank you for trying to tell me, but the late one, that was a knockout. He got up though, and so did you. Say what did.
He wasn't knocked out.
Well, then neither was the other because he got up. Oh,
Was it a TKO then?
I don't know, they're not
I just know he got wrecked.
No, the what's it called? The guy stopped it because his hands
How
got
this
busted.
relates to math?
Okay.
And he broke his hand.
Anyways, so we go to these lessons to find all this information. The whole point though that I was trying to make is fill this out as we're coming upon these concepts. Like be looking at this so that you can fill it out when we do a lesson and ask yourself, hey, did this lesson cover any of these concepts? You can go ahead and make notes about it so that when you go to do any homework I assign, you can use those lessons as a reference point to help you write the equations, to help you understand what type of function we're dealing with, stuff like that. Yes, Lexi, and then KJ, I'll answer your question.
Did we do concavity of a parabola
Yes.
on the gold rush?
We did
Thought
indeed.
that-
Okay.
So I don't think I've assigned that one yet, but it will be showing up. I haven't assigned it yet because it's gonna show up more heavily within the next lesson that we do. But yes, concavity of a parabola will definitely be something you can already fill out within the gold rush.
Miss Beverly wouldn't let me come ask you for a calculator, and then the kid next to me walked in with your calculator. I was like, yeah, Mr. Kitty, let me have it. And I was
Yeah.
like, you're kidding me, right? This is like a computer.
So really quickly, that is a good point. In the future, technically, we're not allowed to let you borrow a calculator for the ACT or anything like that.
You're just the coolest.
Well, it's not that. Just literally, I think it's a dumb rule. Check a calculator out the day before,
But
and then I didn't give it to you. You took it home to do homework.
See, Miss,
Kidding.
I should have just, look, I was thinking, look, I was trying to come to your class, but
I
she
ain't
was like,
had
you
no
can't come.
calculator.
So I was like,
Yeah,
And I'll say this.
They were like,
And
"This
they
kid
did a
will
practice,
do
so I was
this."
just
That's why I was like, well, that's why the rule really is that they don't let you do it during the actual ACT because it gives you an unfair advantage over students who don't have a calculator, which, I mean,
That's
they're not
exactly
wrong,
what
but at
I'm
the same
for.
time, I have 30
Yeah, why
calculators.
don't we just give everyone a calculator?
So,
Now
but
they have-
as a
I
quick
got one.
point, now listen, that means next semester, when y'all are taking the practice and the actual ACT, I won't be teaching you, you will have to remember to come and see me to get a calculator the day
Can
before.
I set an alarm?
You can set an alarm.
our next one's
Um,
December 3rd.
Yeah. Alright, so really
I
quickly,
feel like I could get in touch with.
so I want y'all to notice, like, what is a major concept or a definition that we should put under a linear function? Like, what should we write here?
Constant additive.
Right, so these are things we want to pay attention to. It's got a constant additive rate of change. Is there anything else we can put within, well, like, literally just with that? That's
On a
important?
graph, it would be in a line.
Okay, so we'll get to that in a second, but I'm saying, like, is there any other note we should make about the constant additive rate of change? Maybe what it's called?
It has a common difference.
So it's called a common difference. Oh, that's another vocab word. Looking for those connections. What else is it called?
The slope.
A slope, right? Right, it's called a common difference or a slope. These are the notes that you want to be making so that you can come back and refer to this and you have all of your major notes in one single space. Okay?
I put the equation.
Yeah.
Y equals
Right, y equals what?
mx plus b. Or y equals a.
But now here's the thing, and this is important. You've got an equation. What are some other notes you should write with that equation to make it easier to use that equation in the future? Huh?
The slope is the constant additive rate of change.
We already have that, but so like where do I see my slope in here?
M.
Yeah.
So m, so there's my slope,
And then
B.
b.
and then b over here. And then the b here is my y-intercept. And this a is my, okay. And so we want to make those notes to ourselves, okay? And if I were you, I would even go into a little bit more detail to not just have the equation and define those different things. I might include some information about why that is the equation. I feel like the big thing a lot of us are missing regularly is the understanding of why. And if you're missing the why, then you're really missing the math. These things are not random, right? Oh, by the way, I would also make the note, what is the name of this equation? Slope, intercept. Again, the names are not magical. What two things do you need? You need the slope and the y-intercept specifically, so we call it the slope intercept, right? Everything is honest, not everything, most things in math should make sense. So slope, intercept, form of a line. Okay? And so I would make the note maybe slope is multiplied by x because it is repeated what? Addition. right? Making sense of why all that is there. Because it is repeated addition. How do we calculate slope? And this is important, right? There's a slope formula, m equals, and then there's the slope intercept form of a line. Those are different things. Change in y divided by the change in x. If you're more comfortable with the graphical representation, you could say it is what divided by what? Rise divided by run, okay? Well, remember, it's the change in y, so the way you do change in y is y2 minus y1 divided by the change in x, which is x2 minus x1. Okay? Yeah. And you can do that, but like 3, 7 to, I don't know, 1, negative, let's go negative 3. So to go from 7 to negative 3, what did you have to do? Go from 7, my y value, to the other y value of negative 3. You could do negative 3 minus 7. I'm just saying I'm subtracting 10. Right? That's my change in y. To go from 3 to 1, what am I doing?
2 plus 2.
Not plus 2, because if I'm going from 3 to 1, it's minus 2. So you have to be careful about the plus or the minus, right? But now I have my change in y and my change in x. I actually make this into a little table to do it really easily, right? So I do my table, and so then I see minus 10 and minus 2, change in y, change in x. But I like this better. This is very formulaic, it's fine, it's just students, yeah, I would say it's more complicated. If you are comfortable with that, then you go with it. You do what's comfortable for you. But students regularly mix up the y2, like they'll do, instead of this, they'll do y2 minus y1 divided by x1 minus x2, or something like that, which gives them the wrong sign. When it's supposed to be positive, they might have a negative. Or they'll put the x in the numerator, things like that. They also mix it up with distance formula and midpoint, all those things. So I like the KISS principle. Keep it simple, stupid. There's a comma after there. If you haven't ever heard the KISS principle, that's a business thing, weirdly enough. But keep it simple, comma, stupid. Yeah.
I like that.
I mean, I say it to myself all the time. But yeah, so notice the level of detail I'm giving here is giving me all the key background information that I need to be successful. I've got an algebraic representation there. The constant additive rate of change, remember we find that either in the graph or the table, so I've got that kind of stuff. I might want to make the note that it's 0, comma b is my y-intercept, right? The y value, or the x value is always 0. And then the last note that Gracie even already said is that it's in a graph, it's a line. Like that's that level of detail that you want to go into, so that when you are struggling with linear functions, when you're studying for the quiz, when you're doing your homework, boom, you have everything you need to know in one single space. And you also know, okay, maybe I need to see some of this stuff worked out in an example. Okay, now I have the lessons to go look at. The graphic organizer is designed to help you be successful. And then I do want to make the note, like I would go into a little extra detail with the mathematical representations. First off, what are the key mathematical representations? So there's graphical, which is a graph. Tabular, which is a table. Algebraic, which those are our what?
Numbers,
Expressions, equations, inequalities, all those things. We have two more. We saw this, one of the ones I'm thinking about very heavily in the book, in that M1-17 to M1-27.
The square thing?
So these would be pictures. So we have pictorial representations, pictures, just drawing it out, okay? And then the fifth one, a lot of people forget because you'll almost never translate a function into a verbal representation. You almost always take a verbal and put it into one of the others. But math itself is discovered in the real world. A lot of times it's in verbal representations naturally, and you need to convert it to one of those other representations.
Hey, pardon the interruption, would all Patriot game players, just Patriot game players, please head up to the football field? Thank you.
And so like, things I might make a note of, like those are the representations, but what I might make a note of is why these representations are useful, right? So graphical, you can see the shape, which probably tells you a lot about the type of function if you know the shape. Because if it's a parabola, what kind of function are you dealing with? Quadratic, right? If it's a line, you're dealing with a linear, and then technically it's just called an exponential curve, but if you see that curve, that type of curve, it's exponential, right? What do we see most easily in tabular representations? The rates of change, right? Those are the things that we want to pay attention to. I'll also say the graphical is a great place to find the y-intercept, because you literally just find it on the y-axis. But these are the things that you want to pay attention to. It's not just writing out the basics. The more time you spend on this graphic organizer, the better you're going to understand the math. But you do also need to have taken good notes to get there, okay? So think about that. Right. So, and I'll go back in case anyone needs to continue taking those notes. Yes, ma'am. That practice ACT?
The math portion.
Yeah.
At the end, they always do them things, it said 3 cosine, I don't know what that is, the tan and the
Oh, yeah.
tan.
Oh, that's cheating.
I do
It's
not
like-
know what that is.
Okay.
I like
Hold on. Okay. So really quickly, I will
just
say,
put something.
hold on. You are supposed to first cover that in geometry, but you also have to remember you probably had geometry last year, right? During the middle of COVID, which was a struggle bus and a half. Secondly, huh?
Did it online.
And some of us did it online. But in Algebra 2 with stats, we will not get nearly as far as I want to, but I will make sure that we devote at least 2 to 3 weeks to trigonometry. That is a major part of Algebra 2 with
I
stats.
thought there was a button on the calculator that you could push,
There is a button.
but apparently my calculator didn't have that.
Well, the issue is you have to understand trig ratios to know how to do it, and your calculator probably
On
had it.
They have the TI Inspire 84, they have those signs, but I never know what those are, like, I don't.
You don't know it, but that's the thing, you don't know what those ratios are. I mean, they're on the TI Inspires as well.
Pressing.
If you see trig, they're called trigonometric ratios. If you hit the trig button, it'll bring up every single trig ratio possible. Okay? But you still have to understand how those operations work. Okay?
They know I am a junior and it is COVID, and I did not learn that, so why would they do that?
I feel like our year, like, it's really bad, we're just like not getting as much education because of.
Oh, I got it.
I mean,
That's all of school last.
yes, but here's the
Like
thing.
6 months of school.
I would say there's more than 6 months that y'all got screwed out of, but here's the thing. We are going to do the best we can with what we got, okay? And so we will try to learn and make up the things that we missed. There's only so much we can do. Yes,
You
sir?
teach the same thing with Eqns?
I actually haven't taught Algebra 2 since my very first year teaching.
When was that?
2013? I think it was 2013 to 2014. So it's been a minute. However, I've taught pre-calculus 4 or 5 years, and a lot of these concepts are exactly the same. So I've done a lot of pre-cal, and I've done a lot of Algebra 1, and so Algebra 2 is basically all those things put together. But I've also studied a lot of math.
Caitlin Holman?
Caitlin is not here right now. I don't know, yeah. Why are you laughing?
Caitlin Holman.
It's fine. Alright, so we need to identify patterns as linear, exponential, or quadratic using visual models. Those are pictorial, table of values, or graphs. And we want to be generating those algebraic expressions, or in our case, equations. And so remember, we looked at these 3 different scenarios. We finished everything with Miriam and her flooring company. And we're gonna start on the class president, stuff like that today. So I do want to do a quick recap. If we remember, what was the relationship between the number of tiles in the border for each next,
I think
so we were kept adding 4, right? So for a 1 by 1 square in the center, there were 8 tiles around the outside. And for the 2 by 2, there were 12 tiles on the outside. And for a 3 by 3 center, there were 16 tiles on the outside. So what type of function was it? Linear. And I think, if I remember correctly, everyone in this class wrote this same equation, y equals 4x plus 4, right? And that came from the idea that we were repeatedly adding 4, that was my slope, and then there was a y-intercept of 4. But, and this is something I do want you to notice, there were quite a few other ways that they could be explained, right? And this is one of the reasons why pictorial representations are super useful, because we can actually see the math in different ways. This person, even though they had the same exact expression, they saw it because they saw 4 groups of 3, right? And then 1 corner, or 4 corners, right? So they did 4 times n for whatever that inside set was, and then they added the 4 corners. When we looked here at Howard saw it differently. Howard saw this up here where it was the 3 in the center plus the 2 corners for 5. Same thing down here, and so we had 2 groups. And so that became 2 times n plus 2. But then he saw 2 groups of 3 here, and so that gave him his expression, or his equation. Tyler just said, hey, 3 plus 3 plus 3 plus 3, and then plus the 4 corners, so n plus n plus n plus n plus 4. And so again, the point I'm trying to make is, can you open the door real quick? Yes, ma'am.
Is Cameron Brown in here?
Okay? So the point I want to make is, do you have to use slope-intercept every single time?
No.
No.
But it's the simplest to us.
And that's fine. I just want to remind you that there are other ways to see it, because we're going to start getting into quadratics, and, well, there is no set form you always have to use. So we want to think through those pictorial representations. And that's the other thing. Pictorial representations help us see other ways to think about it. But they were all equivalent, right? When we looked at that one, but hold on. So we plugged in that 135, right? And then we got the same answer out for each of those. We also looked here and used algebraic properties, right? So when we looked at 4 times n plus 2 plus, no, that was 2n, 2 times n plus 2. That was Howard's, right? 2n plus 4 plus 2n, that gave us 4n plus 4, right? Notice when we simplified that expression, it was the same as what we started with, meaning that these 2 expressions were equivalent. They looked different, but they were the same. It was also true for the n plus 2 squared minus n squared. That was the last option. And a lot of us looking at that were like, there's a square there, so we thought it was what type of function?
Exponential.
Not exponential.